Let's take a look at derivatives of inverse functions. And our formulas, we're looking at arc sine, arc cosine, arctangent, arc cosecant, arc secant, and arc cotangent. And the u can represent anything. The u prime at the end is for the chain rule. That's where you have more than a single variable following your arc whatever function. Arc sine, arc cosine, and so forth. And basically whatever u is, you just plug into the u into the formula. So let's take a look at a problem. We got f of x is equal to arc secant of x squared minus 3x. Okay, now whatever's inside the parentheses is always going to be our u. So when we're using a formula, that's going to be our u. So for our derivative, let's go look up arc secant. Arc secant is going to be 1 over the absolute value of u, so the absolute value of x squared minus 3x, times the square root of u squared minus 1. So we're going to have x squared minus 3x to the second power minus 1. Times, and the u prime here at the end is the chain rule. So we're going to multiply it times the derivative of what's inside the parentheses. Again, you identify your u, you plug it into your formula, and then at the end you have to multiply it times the derivative of what's inside the parentheses. Unless it's a single variable like an x or so forth. Well, the derivative of x squared minus 3x gives us 2x minus 3 over the absolute value of x squared minus 3x times the square root of x squared minus 3x to the second power minus 1. And that's our answer. Number 2. We got h of x is equal to x to the third arc sine of 4x. Well, this is a product rule. We got something times something else. So our x to the third is going to be our p, and the arc sine will be our q. Well, we need p prime for our formula. The derivative of x to the third is 3x squared. We also need q prime. Let's go look up the derivative for arc sine. If I come over here at arc sine, it's 1 over the square root of 1 minus u squared. So 1 minus, and u again is whatever's inside the parentheses. So this will be 4x to the second power. Times, and then you multiply times the derivative of what's inside the parentheses. So we're going to multiply times the derivative of 4x. Now the derivative of 4x is 4, so I'm going to have 4 over the square root of 1 minus, and 4x to the second power, 4x times 4x gives us 16x squared. Now our formula says p prime q plus p q prime for our product rule. So for h prime, we got p prime, which was 3x squared, times q, which is arc sine of 4x, plus p, which is x to the third, times q prime, which was 4 over the square root of 1 minus 16x squared. Now we'll do a little bit of simplifying here. I can factor out what they have in common. When I say what they have in common, this is considered one group because everything's multiplication. 3 times x squared times arc sine. And this is considered one group because we've got x to the third times whatever's inside of parentheses here. Well, they both have an x squared in common, so I can factor that out. And that leaves us 3 arc sine of 4x. And we had x to the third here. We took 2 away, so that leaves us single x. So we got plus 4x over the square root of 1 minus 16x squared. Now, I doubt if they actually get a common denominator in these in the book, but in case they do, we can always put the 3 arc sine 4x over 1, and so then we multiply the top and bottom by the square root of 1 minus 16x squared to get a common denominator. So if I merge these into a single fraction, we would have 3 square root of 1 minus 16x squared arc sine of 4x plus 4x all over the square root of 1 minus 16x squared. Now we could take that x squared and put it up on top here if we wanted to, but this is fine. Again, what I did is to get a common denominator, I multiplied top and bottom by square root of 1 minus 16x squared. Let me save that. This is derivatives of inverse functions. Calc 1. Derivatives. My eyes are bad. I can't even see what I'm typing. Derivatives of inverse functions part 01.pdf. There we go. Part 01 should be page 01. Oh well, I'll change that later. Kind of skipped a few steps on that last one because I was running out of space there. Okay, let's take a look at this one. Got f of x is equal to arc sine x plus arctangent x. And we want to find the derivative, I'm assuming. Yeah, find derivative. So let's take a look at our formulas. Now notice these here, these are single x's, aren't they? So I don't need to worry about putting the u prime on at the end. I'll just plug the x in for the u and then call it good. So for arc sine, the derivative of that is 1 over the square root of 1 minus u squared, so this will just be 1 minus x squared. Plus arctangent, the derivative of it, here's arctangent, that'll be 1 over 1 plus, then the u squared becomes x squared. And again, we don't need to worry about the u prime at the end. That's only for the chain rule. Now these don't have the same denominator. So if I were to get a common denominator, I'd have 1 plus x squared times the square root of 1 minus x squared as my common denominator. There we go. Now you have to look at your old denominator and see what new thing was put down there. On our first fraction here, we had the square root of 1 minus x squared, which is still there. The new item downstairs is the 1 plus x squared. So we had to put up on top also. The mathematical rule behind that is whatever you multiply by the bottom, you have to multiply by the top. Now over here, we had 1 plus x squared. That's still there. The new item downstairs is the square root of 1 minus x squared. So we have to put that up on top. Again, whatever you multiply by the bottom, you have to multiply by the top. Well, now they have the same denominator, so I'm going to merge together the top parts. So I'm going to have the 1's don't add anything, 1 times anything. So I'm going to have 1 plus x squared plus the square root of 1 minus x squared. All over 1 plus x squared times the square root of 1 minus x squared. And that's our answer. I probably have room for that, but let me save this page just to make sure. And I'm not going to call that part 1. Call this page 02. There we go. And let's look at our next problem. Okay, we got y equals x to the third arc cosecant of x squared minus 1 minus 1/2 natural log of 3x squared minus 4. And instructions still find derivative. Well, if I look at this, the first part here, this is a product. We got x to the third times arc cosecant. So this will be p and this will be q. For our formula, we need p prime. The derivative of x to the third is 3x squared. And we need q prime. The derivative of arc cosecant. And whatever's inside the parentheses right here is your u. So u is equal to x squared minus 1. Let's go look at our formula for arc cosecant. Arc cosecant is negative 1 over the absolute value of u. It's the absolute value of x squared minus 1. Square root of u squared minus 1. So I'm going to have x squared minus 1 to the second power minus 1. That seems weird. Remember, use whatever's inside your parentheses. So we got our u squared minus 1. So there's our u squared minus 1. Now, we're going to multiply it times the derivative of what's inside of parentheses. So we'll multiply it times the derivative of x squared minus 1. Because this is a chain rule. Anytime you have more than a single x here, you have to multiply it times the derivative of what's inside of parentheses. Well, the derivative of x squared minus 1 is 2x. So I got negative 1 times 2x. That gives us negative 2x up on top. And the absolute value of x squared minus 1 times the square root of x squared minus 1 to the second power minus 1. Now we'll get to the natural log here in a second. But our formula for the product rule is p prime q plus p q prime. So p prime was 3x squared times q, which was arc cosecant of x squared minus 1, plus p, which was x to the third, times q prime, which was negative 2x, over the absolute value of x squared minus 1 times the square root of x squared minus 1 squared minus 1. Okay, now let's go to this natural log. So minus 1/2. If you got a number out in front stays on front. The derivative of a natural log of something is 1 over whatever's inside the parentheses times the derivative of what's inside the parentheses. So again, let me recap that. Natural log, the derivative of natural log is 1 over whatever's inside the parentheses times the derivative of what's inside the parentheses. Okay, so this gives us 3x squared arc cosecant x squared minus 1 minus positive times a negative 2x times x to the third gives us 2x to the fourth over the absolute value of x squared minus 1 times the square root of x squared minus 1, all of it squared, minus 1, minus the derivative of 3x squared minus 4 is 6x over 2 times 3x squared minus 4. Well, I'm going to do some simplifying here. I notice I got 3 groups. This is our first group. We got this times this times this. Everything's multiplication. And this is just a single fraction, and this is just a single fraction. So those are the logical groupings. And I look at those and notice they all have an x in common. So I'm going to factor out an x. And then that gives us 3x arc cosecant of x squared minus 1 minus, one of those x's are gone, so that's 2x to the third, over the absolute value of x squared minus 1 times the square root of x squared minus 1 to the second power minus 1 minus, that x is gone, and 6 divided by 2 is 3. So we got 3 over 3x squared minus 4. Now, there's really no benefit to us merging these together beyond what we just did. So that'd be our answer. Let me save that. If I can rename that here. Let me see. Rename page 01. Okay. Then I want to save this next one as page 3. Okay. And time for my tablet to blow up, so I'll bring up a new one. And let's look at our next problem. This one here. Again, we want to find derivative. So we've got y is equal to 9 arc sine of x over 3 minus x times the square root of 9 minus x squared. Well, I want to rewrite that before I take derivative. So this would be 9 arc sine of x over 3 minus x times 9 minus x squared to the 1/2 power. So we want to write it as fractional power, rational exponents. And the square root is always the 1/2 power. Well, the arc sines will be pretty straightforward, but this over here is the product rule. So P is going to be equal to x, and Q will be equal to this 9 minus x squared to the 1/2. We need P prime. The derivative of x is 1. We need Q prime. I guess I shouldn't do that in red. Some people are red-green colorblind. There we go. Q prime. This is a chain rule, specifically a general power rule. You take your power, which is 1/2, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply times the derivative of what's inside the parentheses. So again, if you have parentheses to a power, taking the derivative, you take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1 times the derivative of what's inside the parentheses. Which gives us 1/2 times 9 minus x squared to the negative 1/2 times the derivative of 9 minus x squared gives us negative 2x. Now I want to merge these into a single fraction, so we're going to have negative 2x over 2, and then this negative 1/2 power goes downstairs, goes down to the denominator, and we've got 9 minus x squared to the positive 1/2. 2's cancel, and we've got negative x over 9 minus x squared to the positive 1/2. Okay, now we're ready to find our derivative. Okay, so for y prime, the 9 stays out in front, and times arc sine. And again, the x over 3 is our u. Well, let's go look at our formula for arc sine. Arc sine is 1 over the square root of 1 minus u squared. So we're going to have 1 minus x over 3 squared, because that's our u. Times, and since we got more than a single variable here, we have to multiply times the derivative of that. So multiply times the derivative of x over 3. So again, we identified this as our u, the x over 3. We put that into our formula everywhere we have a u, and then we might have to, by the chain rule, multiply times the derivative of u. Okay, then P prime. P prime we said was 1 times Q, which is 9 minus x squared to the 1/2 power, plus p. If I got my negative out in front, don't I? I don't want to drop that. Almost screwed that up. Okay, so I got a negative out in front. Now put brackets because that affects everything that follows it. So p prime times q, so 9 minus x squared to the 1/2, plus p, which is x, times q prime, which is negative x, over 9 minus x squared to the positive 1/2. Okay. So then this becomes 9 up on top times the derivative of x over 3. That's 1/3 x. So the derivative of 1/3 x is 1/3 over the square root of 1 minus x to the second power is x squared. 3 to the second power is 9. So 1 minus x squared over 9 minus, and I'm going to put this into a fraction form, so this will be 9 minus x squared to the 1/2 over 1. Positive times a negative is negative, and x times x is x squared over 9 minus x squared to the positive 1/2. Well, 9 times 1/3 gives us 3. And down here, I want to get a common denominator. So this becomes 9 over 9 minus x squared over 9. Minus. Now, I want to get a common denominator in here, and I'll multiply two denominators together, and I find my common denominator is going to be 9 minus x squared to the 1/2. Excuse me. Now our second fraction already had that, so it's good as is. Our first one, we multiplied the bottom part by 9 minus x squared to the 1/2. We have to multiply the top part by 9 minus x squared to the 1/2. So we'll have 9 minus x squared to the 1/2 times 9 minus x squared to the 1/2. Now over here, this is going to be 3 over, and I will put this as a single fraction. So we're going to have square root of 9 minus x squared over 9 minus 9 minus x squared to the 1/2 times 9 minus x squared to the 1/2. Since these are the same, you're going to add the exponents. 1/2 plus 1/2 gives you 1. So this is going to be 9 minus x squared. And since they already have the same denominators, I'll merge these together. So minus x squared over 9 minus x squared to the 1/2. Okay. Over here, I want to, down below I got a square root of a fraction. I can split it up, put a square root around top. So square root around 9 minus x squared, and square root around the bottom. Minus, we got 9 minus 2x squared, combined together like terms, over the 9 minus x squared to the 1/2. Now, over here, we got the square root of 9 minus x squared, and square root of 9 is 3. Minus 9 minus 2x squared, and this 1/2 power, I'm going to go ahead and put that in square root form. So this is going to be 9 minus square root of 9 minus x squared. Now back to our first fraction, we have a single fraction down denominator, so we're going to flip it and multiply it times our top part. So we're going to have 3 times 3 over square root of 9 minus x squared minus 9 minus 2x squared over square root of 9 minus x squared. Now 3 times 3 is 9, and I want to merge these into a single fraction at this point. So this negative, remember, is going to flip the sign of everything up on top. So like I say, I got 3 times 3, which is 9, and that gives me negative 9 plus 2x squared over the square root of 9 minus x squared. Well, 9 minus 9 cancels, and we end up with 2x squared over the square root of 9 minus x squared. Assuming you didn't make any basic algebra mistakes. And that's your answer. Quite a bit of simplifying on that one. Let me save that page. Okay, let's look at this one. Now this says find dy dx at the given point for the equation. Now, when it says find dy dx at the given point for the equation, remember the problems earlier where we found the slope of the tangent line? Well, that's basically what we're going to do here. So it's the same steps as what we did there. We're going to first find our derivative. Now after we find our derivative, then we'll plug in our given point for x and y in this case. And that's going to give us our value. So let's take a look at this. We've got 2x arctangent of x is equal to -3 plus e to the y. And I'm going to use implicit differentiation. Makes this one easier, I think. What's our point? 1 natural log of pi over 2 plus 3. Okay, so we're going to take the derivative of everything where it's sitting. So we're going to take the derivative with respect to x of 2x arctangent x. We're going to take the derivative with respect to x of -3. And we'll take the derivative with respect to x of e to the y. Now this first part here, this is a product rule. We got 2x times arctangent. So 2x is going to be our p, and arctangent of x will be our q. Now we could put the 2 completely out in front, but you can also include it in with one of your either p or q. It doesn't matter. Well, we need p prime. The derivative of 2x is 2. And we need q prime. And if we go look at our formula sheet for arctangent, it's 1 over 1 plus u squared. And we just got a single x here, so this will be 1 over 1 plus x squared. We don't need to do our u prime at the end, because this is not the chain rule. Okay, or it's a very boring version of the chain rule. We got p prime q plus p q prime. So let's plug in. P prime is 2 times q. That's arctangent x plus p, which is 2x, times q prime, which is 1 over 1 plus x squared, equals the derivative of -3 is 0. And the derivative of e to the y is e to the y. The derivative of e to the power doesn't change. It's just e to the power. Now we're taking derivative with respect to x, and this is really a y, so we have to throw on our y prime. Or you could put on dy dx. Look, I think the problem's indicating. So, see, find dy dx at a given point. I like y prime because it's a little bit easier to do calculations with. Okay. So we got 2 arctangent of x plus, put that 2x up on top. We got 2x over 1 plus x squared equals e to the y prime. Now, we want to solve for y prime, and always your first step in solving for y prime, and I'm doing a simplification here just so you can see it. We don't actually have to, and I'll talk more about that in a second, but always our first method of solving, our first step of solving is, well, first is get rid of parentheses, of course, but second one is get rid of fractions. And you always do this the same way. You multiply everything by the LCM of all your denominators. Now, we only have one denominator, the 1 plus x squared, so we're going to multiply everything by 1 plus x squared. So we'll have 2 times 1 plus x squared times arctangent of x plus 1 plus x squared times 2x over 1 plus x squared equals e to the y times 1 plus x squared y prime. When we do that, these 1 plus x squared is going to cancel. And we'll have 2 times 1 plus x squared arctangent x plus 2x equals e to the y 1 plus x squared y prime. Now our goal is to get the y prime by itself, so I'm going to divide both sides by what's in front of our y prime. So we're going to divide both sides by e to the y over 1 plus x squared. So e to the y over 1 plus x squared. And do the same thing over here. Now on the right side, when I do that, my e to the y is going to cancel. My 1 plus x squareds will cancel. And I get y prime is equal to this over here. Let me get it all written down. What a mess. Okay. Well, now they want us to find the dy dx at a given point. So we want to plug in that point. So our x is equal to 1. So we'll put 1 in for the x. So I got 2 times 1 plus 1 squared arctangent 1 plus 2 times 1 over e to the y. And y is the natural log of pi over 2 plus 3. So this would be natural log of pi over 2 plus 3 times 1 plus x squared. And x we said was 1, so we got 1 plus 1 squared. Now before, when we found the slope of the tangent line, we changed that to m, but we don't have to do it here. Okay, 1 squared is 1 plus 1 is 2, so 2 times 2 is 4. So we got 4 arctangent of 1 plus 2 over 1 squared is 1 plus 1 is 2, so that's 2e to the natural log of pi over 2 plus 3 equals y prime. Well, let's look at arctangent. Arctangent is valid from negative pi over 2 to pi over 2. And let's set it equal to a variable. I don't know, set it equal to p. So we're trying to find out what the value of arctangent 1 is. Well, if I take tangent of both sides, I get tangent p is equal to tangent of arctangent of 1. So tangent and arctangent cancel each other away, and you just left with 1. Well, remember, tangent is y over x. So if I go around my unit circle, here at pi over 4, we have square root of 2 over 2 and square root of 2 over 2. And that's in my range from negative pi over 2 to pi over 2. Well, y over x. If I put square root of 2 over 2 over square root of 2 over 2, that gives me 1. Which must mean that p is going to equal to pi over 4. So back over to here, this becomes 4 times pi over 4 plus 2. And then we got 2 here. Now, the e and the natural log, if you remember those from college algebra, cancel away. And that gives us pi over 2 plus 3. That's y prime. Now those 4's cancel, and we got pi plus 2. And here, when I multiply 2 through, multiplying it times the pi over 2, which gives us pi, and 2 times 3 gives us 6. So our answer is going to be pi plus 2 over pi plus 6. That one worked out interesting. Let me save that. Okay. Let's take a look at this one. Got f of x is equal to arc cotangent of x in 1 pi over 4. Okay. Let me shift position here in my chair. There we go. The instructions: find the equation of the tangent line. Well, our first step is to find derivative. So f prime, the derivative of arc cotangent, and if we come back to look at our sheet, arc cotangent is right over here. It's negative 1 over 1 plus x squared. Now notice we just have a single x here, so all we do is replace the u with x. We don't have to do the u prime. Because if you think about it, if this was u, the derivative of x is 1 anyway, so it would drop away. Well, step 2. We want to change our f prime to m, and then plug in the x and, if necessary, the y part of our point. It's not necessary. We just need the x here. So we give us this point, so x is equal to 1. So we got negative 1 over 1 plus 1 squared. So we got negative 1 over 2. Now we want to plug in the given point for x and y, plug in the m we found in step 2, and then solve for b. Well, y was pi over 4, so I'll put that in. M we said was negative 1/2, and x is 1, and then plus b. So we're going to have pi over 4 equals negative 1/2 plus b. Now I'm going to take the negative 1/2 to the left side, and it becomes a positive 1/2 equals b. Want to get a common denominator. So in the second fraction, I multiply top and bottom by 2. So that gives us 2/4. Now they both have the same denominator, so I'm going to have pi plus 2 over 4 is equal to b. And then we can't forget step 4. Step 4 is actually write your answer down. Well, m we said was negative 1/2 from step 2. And b we said was pi plus 2 over 4. So that'd be our equation of the tangent line. Let me save that page. There we go. And go ahead and stop the recorders. Derivatives of inverse functions.